All right, welcome everyone to How to Hex. This is the September edition where we're covering chained SQL, which is a specific workflow in Hex that I'm going to demo and talk about for you. If you haven't come to a How to Hex session before, the general gist is that this is a very slide low demo session. I'm going to hit the next button in one moment and it's not going to have any more slides. It's going to say demo. And I'm going to actually dive into Hex and orient you a little bit to the Hex platform, show you how this specific aspect of the platform works for about 15 minutes or so. And then we'll have about 15 minutes for freeform general questions about anything. And I'm happy to live walk through any parts of the product that you're interested in. Sound good? Great. So as promised, we're going to go directly into the demo. I am going to cancel this. And now that I'm not full screen, let me know if you can't see my screen in the chat, but I think that it should still be visible. So this is a Hex project. It sounds like most of you are familiar with notebook concepts. So this should look like familiar to you in some sense. We have a bunch of different cells. Here's a text cell. I can add a Python cell in this notebook and print some output. This kernel's just starting up. There's a whole bunch of other cell types in Hex. So really the whole workspace is oriented around this concept of a notebook, but we've gone and added a ton of custom native cell types, everything from input parameters, which you can think of as sort of like IPy widgets. They're ways to accept user input and then use that to parameterize your code or queries. There's native chart cells, maps, table displays, data transformation cells. So we've taken the notebook concept and really built on it, built all of these native tools to make it even easier to use. One of the most important additions are SQL cells. So if you've ever had to get data into a notebook before, you probably have gone through the schlep of either downloading and just uploading a CSV file or doing like SQL alchemy and establishing a connection and then writing your query in block quotes, and it's just like a pain. You don't have syntax highlighting and it kind of sucks. So we built a completely native SQL cell into Hex that has syntax highlighting. It connects directly to your data warehouse. So you can actually browse all of the columns that you have available. You can cache things really cleverly, so everything's super fast, and you generally just have a much more delightful SQL editing experience in Hex. That is kind of table stakes. So here we're running a simple SQL query, getting back some results. It's returning a data frame called data frame 6, and I'm taking this data frame and then using it in a Hex chart cell. So that's just a small glimpse of the standard Hex workflow. You are in a notebook, you can write some SQL, you can write some Python, everything, even SQL queries, return data frames that are easy to use in downstream cells. Just like a notebook, we just happen to have some new cell types. Today, we're going to talk specifically about something called chained SQL, which I think is actually maybe the one part of Hex I probably couldn't live without if I went back to another notebook. I was kind of preparing for this and being like, oh my God, I can't believe that some notebooks don't have this, because it just feels so intuitive and lovely after a couple of years of using it. So the basic concept is that every SQL query in Hex returns. I'm just going to run everything in this project so that we have everything already. Every SQL query in Hex returns a result object. And in sort of a standard notebook or SQL IDE or something, it's okay, I ran this query, I got some information about order dates, categories, everything else. If I want to drill down into this and maybe change the aggregation on this or something, I'll write a new SQL query, right? It's okay, I learned something about this data and now I want to roll this up by category. So I'll delete that, do category, and then account star and change the grouping. I'll edit the SQL query, rerun it, and I'll lose my work basically. Or I'll do a whole new SQL query and copy and paste it. Hex lets you chain SQL queries together. So you can take the output of any SQL query and add it to a new SQL cell. And basically, you just reference it just like you would a table from your data warehouse. So here we're running a select, rolling up our orders by category, but we're selecting from order details, which is this SQL query that we just wrote. And so you can do this kind of like iterative aggregating work in Hex and drill down through the entire life cycle of an analytics workflow without having to ever copy your work, like repeat yourself, write these long, crazy SQL queries. And you can see everything as you go. So it's like, oh yeah, I want to actually look at the like data that I'm rolling up here. All you have to do is scroll up for a moment. This is all powered by an in-memory database. We use DuckDB to power all this. So it's really, really, really fast. If I run this, it like always takes 0 seconds, basically, no matter how big the data set is, because DuckDB is wicked fast. And this can save you on warehouse compute, because basically this SQL query is running against Snowflake, and then it's returning a data frame in Hex, so we can reference in Python. But this data frame is also being loaded into a local DuckDB database that we can write data frame SQL against. And this SQL query is not going off to Snowflake. It's staying within Hex. So no matter how massive the data set you're operating on here is, you can run it super quickly in Hex. It's data frame SQL and never hit your database. It's super quick. And this is part of why you can build like really powerful interactive apps in Hex, because you can pull down a big data dump at the beginning, maybe then you cache it, and then you can run a ton of really fast in-memory queries throughout the rest of your project and use those to power an end-user facing app. So let's keep exploring down this project. You can see that I'm continuing to run queries against order details and roll this up. So here we're getting roll up by menu item, where category is dumplings. So this is basically just a dumpling data set. This demo data set is a dumpling store. We're returning a dumplings data frame here. Then I'm running another SQL query against just dumplings to roll it up by menu item from within dumplings. And then I'm throwing dumplings into a chart. And again, this is the kind of thing where you can imagine, like, either I would be rewriting the SQL query, or I would be doing this with CTEs, where I'd say like with dumplings as this. Oops. Then I would say like this, and you get this like sort of messy, big exploding CTE style workflow. And in Hex, the chain SQL workflow means that you can just have these two nice atomically separated cells, and you can debug every individual part of the query without having to like comment out parts of your CTE and forget a parenthesis and stuff. So that's one part of the chain SQL workflow. Like this project basically is taking a SQL query, returning order details, and then chained SQL queries onto it that roll up various different aggregations and dive into specific aspects of the data, like the amount of spicy menu items or the amount of dumplings. And this is all using that data frame SQL database that I talked about to run like fast in-memory queries. But there's another aspect of chain SQL as well. So I'm going to turn this back to data frame. Chain SQL with data frames works great against like small to medium-sized data sets because it's super fast. But for huge data sets, it doesn't make sense to bring it all in as a data frame. Like you can see here, I'm running this query. It's returning like 20 million rows. It's taken forever just because it has to stream back 20 million rows worth of data over the internet from Snowflake. So it took like 20 seconds to stream all of that data back from Snowflake because it was 7 gigabytes of data. And I can fit all of this into my like local in-memory DuckDB warehouse, but it's just a pain to have to like wait 20 seconds for that query to come back. And you could imagine if you were working with, I don't know, 70 gigabytes of data, you had 200 or 500 million rows, this workflow actually would just stop working because like you can't pull 70 gigabytes of data into a local Python kernel. It's just too slow. But we want to be able to work with this data set and not have to like write the perfect query on the first go that aggregates everything properly and returns just the smallest subset. We want to do that like chain SQL workflow, right? Where we run just a big select star and like, oh, this is the data we have, then sort of filter it down a little bit, then aggregate it. But you can't do that with 70 gigabytes of data, or you can't do it fast. So we've built this thing called query mode, which also works with chain SQL. So I'm going to change this to a query. And instead of returning the entire data frame results, so like every row, Hex is going to rerun this, and it's only going to return 100 rows as a preview, but it's still run the query in the background and kept the results cached over in Snowflake. So that returned in 0 seconds. I still have all this data here, and I can be like, okay, this is what I'm working with. And then I can chain queries onto the query. So I'm going to write a chain SQL query on top of this query. Maybe we want to look at total count of users for our like first 500 start stations. We'll run this, and this is a small enough query that I can return it as a data frame. So I'm not going to put this in query mode. And this is going to, behind the scenes, basically compile a CTE with query 3 as this, then run this. And this is cleverly cached, so it happened really fast. We didn't wait 20 seconds, and I didn't have to worry about writing this CTE and repeating myself. And more importantly, if I'm like, what is in there? Then I can just scroll up and actually look at it. I don't have to comment things out and rerun the query again. And so this was like a simple case where we immediately got a really small data set out of our second chain. But you can also imagine doing a much more iterative process. So let's say like, we'll select star again from query 3. And maybe, again, we want to look at like where trip duration is more than 500 or something. And this is probably going to be a pretty big data set. So I'm going to put it back into query mode. We'll chain another query onto that. Again, it runs like ASAP. Maybe I want to be like, how big is that? So I'll say, I'll look at the count of query 4. And it's like, oh my God, wow, that's still huge. So I don't want to return all of that. So maybe I'll filter it down again. I'll say like select star from query 4 this time, where we already filtered on user type, I think, where and station ID is greater than 500, like we did that last time. And this I know is small enough that I can actually bring it back into memory. So I won't run this as a query. So you can do these like really complex query chains on massive data sets. And this was still pretty big, so it's taking a long time, and I'd be much better served turning this into a query. So you can build these chains on massive data sets, and everything is super, super, super fast, like way faster than it would be if you were rewriting things and copying and pasting, and way faster than it would be if you were just writing normal queries or returning their entire results into memory. Yeah, this like query chained workflow, you won't really like notice the magnitude of it until you've used it for a real case where you're working with a ton of data and you're like, oh, this is taking so long to return. And then when you do, it's going to blow your mind. There's one thing I want to show before we jump into questions, because I see a lot. What was I going to show? Yeah, so here I showed you like starting with a chain workflow where we like wrote a query, asked some questions, iteratively worked through it, and chained queries on top of one another. Hex has a built-in way to turn complex CTEs into chain SQL queries. So here's a CTE. It's like pretty standard stuff, running some user sign up data, looking at monthly events, and then returning a bunch of that information here. I don't know why I'm doing this. Leftover did nothing, I think. So if I run this, it's fine, but it's kind of hard for me to debug each of these individual sections. And like, it's very possible that I'm getting incorrect results in my outer query because of something going on inside of the CTE. What I can do is use Hex's magic AI features to explode the SQL query into a chain of SQL queries. So it's going to be thinking for a moment, it's exploding this query. It says 3 new cells created. I'll delete the original one. And now I have 3 chained SQL queries, one for each of the inner CTE queries, and then one for the outer query. When I rerun the last one, Hex's reactive execution model goes and finds all of the other ones and runs everything that it needs to get this final result set. And in fact, now that I can see the results, I feel like I can see, oh, I'm actually returning some rows here for users that are null, and this could be affecting my final result. So I'm going to just quickly set this to be where user ID is not null. I'll rerun this query. And again, the reactive execution means that this query will also reactively re-execute. And now I'm getting the correct results. It was super easy to debug this CTE query because I split it into chains. And if I hadn't done that, I would never have known that I had some missing data in that inner query. We have 13 minutes left. I want to leave time for questions, but there is one more thing that I want to show. Let me find a project to show you. You might have already guessed this, but the fact that you can write SQL queries against any data frame in Hex means, yeah, you can chain SQL queries together into compositions of multiple SQL queries, but you can also write SQL against the output of Python operations. So here in this project, I'm doing a forecast in Python using profit, again, on that dumpling data set. And I can take this forecast data frame, which actually has like predicted values, and I can query that with SQL. And oftentimes it's just a lot easier than having to stay in Python land, or you can imagine like almost this entire project is in SQL. And then we dipped into Python for 4 lines of code to build this simple forecast. It's like, well, now I want to just go back to SQL and query this. You can just query this with data frame SQL. This applies to any Python operation you can think of. Anything that returns a data frame, you can query with SQL, and then we can keep chaining SQL queries on top of that. Cool. That's the power of chain SQL. I hope that breakneck walkthrough of all of this was enough. It's also really clearly laid out in our docs, and there are a bunch of example projects on our use case page. Actually, some of the example projects that I used today are from here. If you go to exploratory analysis and look at SQL notebooks, you'll be able to follow along with that dumpling exploration analysis that I walked through. Cool. Make sure to ask your questions in the chat or using Q&A. I am gonna open this up and look at what you asked. Yes, so Pranav said the same object can be used in Python script. Yeah, I think that you must have asked that before I showed that. You can interchangeably use SQL and Python to operate on any data frame object. Is there ability to prename the panda df returned from the query instead of using stuff like query 3? Yes. I was just being lazy and fast here. So let's take this data frame here that's returning some spicy stuff. And, oh, actually, I'm gonna show you something cool. So first, before I do this, I'm gonna just print this out, and then maybe I'll add a SQL query that collects everything from data frame 5. And then I'll take this and be like, oh, data frame 5 is a terrible name. I'm gonna change this to spicy rollup. Hex will automatically go and find all those references and rename them so you haven't broken the entire notebook when you're like, oh, I want to clean this up and rename stuff. That is another excellent Hex feature. Thanks, Mark. Yeah, I know. That is like always the sleeper exciting thing. It's actually pretty cool, since we don't have any other questions right now, I think. The way that some of this stuff that you were seeing where the like SQL queries automatically rerun based on what you're doing and how this renaming worked, Hex actually models the entire notebook as a graph. So rather than just like linear flow, 1, 2, 3, 4, 5, 6 cells, we actually compute all of the dependencies, both parent and children, for every cell. So if I take this SQL query and I rerun it, we'll see just the downstream dependencies of it rerun. But you'll notice that like this query did not rerun and this chart did not rerun because it didn't need to, because it doesn't rely on this data. So no matter how complicated the like visual apparent order of your notebook is, it always runs super fast because it's only re-executing the things that it actually needs to get whatever you just did. So that's pretty cool. Exactly. What's the upper limit for data cached in DuckDB? I don't know if I have a like specific example or a specific number for you. DuckDB is like super powerful and can theoretically handle however much data you want to throw at it. the standard hex kernel sizes are like 8 GB, 16, 32. I think you can call us if you need more than that. So those would be the upper limits, right? Because in order for it to work using data frame SQL, it needs to be returned all the way into memory. So I would say like 32 GB is probably the upper limit for working with data frame SQL, just because that is the size of our notebook kernel memory. But again, you can always use query mode. And what I didn't show here, I'm not sure if you all are familiar with Snowpark. It's like Snowflake's compute pushdown mechanism. I'm not going to dive deep into it today, but basically we've built in native support for Snowpark. So in addition to returning a query object, you can also return a Snowpark data frame. And then again, you can chain SQL queries onto Snowpark data frames, pass them into charts, use them in Python cells or whatnot. That's just another way to like push down compute on massive data sets out of that in-memory kernel. Does that make sense, James? Mark says, is pricing affected by the amount of data moving to Hex? No, it is not. You could theoretically save some money on your warehouse compute by like being really judicious about using data frame SQL. I think if you have like good warehouse hygiene in general and have like accurate like timeouts and auto stopping and suspension and whatnot, honestly, I think you should probably just do whatever feels like fastest and best. I don't know that like, I mean, if you're running truly massive queries, then yeah, you could probably save some money by using data frame SQL. But I actually, maybe I'm being too honest, I think that it would be really cool if Hex was like clever enough to collapse all of these into just like some intelligent choice of like, do you want a data frame? Do you want a query based on the size of the data set you're querying, like your past habits? I don't know that you need to like spend a ton of time worrying about, oh, should it be a data frame? Should it be a query? I think it's like, we should just do whatever is fastest. So I wouldn't worry too much about the amount of data you're moving. How's integration with BQ? Yeah, BigQuery works fine. Our default demo data set is just in Snowflake, but there's a BigQuery in here somewhere. Yeah, everything works exactly the same way. We have the schema browser still working. I actually have the same city bike trip data set in here. We can grab some data out of BigQuery. And I don't have it enabled because it's brand new, but just like how Snowpark works with Snowflake to return these like push down data frame objects that you can operate on with pandas syntax. And I think there's like a BQML, big frames ML thing. We have support for big frames as well coming out soon. So you'll be able to work with that just as natively as Snowpark data frames. James said, what is a magic action? Did you see that pop up somewhere in the UI? I'm not diving into it too much today, but magic is what we call our suite of AI features. So let me find a query that I didn't just break. Maybe we'll go back to a different project, or I'll just back this up. We've built an AI toolset into every single cell. We have magic generate, edit, fix, explain, and you saw explode, which works on CTEs. You can use these to write completely new code. Maybe we can tweak this and say like, roll, I don't remember what data we're working with here. I'll say just like, only look at dumpling orders. We built this like super native integration with AI so that you don't have to go back and copy and paste from ChatGPT. You just ask your question here and it rewrites your query right here. And you can see a nice neat diff and then keep it and rerun it. And I think I did something wrong here with the wrong data connection. But anyways, you have a ton of AI tools like right here at your disposal to write queries, edit Python code. I have some really cool stuff coming down the line here, so stay tuned. Troy says, give us a crumb of a wicked new feature. I was moments away from doing that, Troy, just milliseconds ago, and then I decided not to. You'll have to come to the live stream on October 5th to see what we have cooking up. Although, actually, if you've been using Hex, you might notice everything just looks a little bit new and shiny. That can be your breadcrumb. I'm already using the Hex 3.0 visual styles. Pranav says, can we embed charts from Hex into web pages? Yeah, let's check this out. We actually do this on our website a bunch, which is probably a great example. If we go to our use cases, we have a ton of use case examples of just like doing cool stuff in Hex here. And if you click into any of these, you'll see that you can explore a live demo, and we're embedding a Hex app into this web page. If it loads on my crappy internet. While I wait for that to load, if I pull up, there it is. So yeah, you can embed it. You can change the sizing and everything. It's completely interactive. And you can also embed the logic view, although this is sort of less useful unless you work at Hex and want to show off how the cookie's built. But yeah, you can do embeds. You can also embed individual cells. This works really nicely with like Notion. You can actually just copy and paste a cell link into Notion and it'll automatically expand and embed. And yeah, if you're in any project, you can just grab the share menu, click embed down here, and then you'll get either an embeddable link that you can do in like Notion and whatnot, or some iframe code that you can paste into a website. Mark, you should totally become a data scientist. If you're watching the How to Hex webinar, I think you already might be a data scientist. Should update your resume. Cool. We've got about a minute left. I'm happy to take like one more question if there's anything else. But if not, I hope everyone has a lovely day. If you have any questions about Chain SQL specifically, feel free to email me. I think that I sent you some email invites to this, so you should be able to just reply to them and I'll answer any of your questions. And yeah, happy to tell you anything about Hex or any specific features. Thanks, y'all. Thanks for coming.